All right, so 8.4 number 12 says Ashley boards the Ferris wheel at the Pacific National Exhibition. When the ride begins, her position can be modeled by the function given here. So we've got 43 sine 3.5 x minus 0.9 plus 47. So all of these little parameters are going to mean something to the graph and to the situation. So y represents the height of the Ferris wheel, and x represents the time in minutes. So determine the diameter of the Ferris wheel. Okay, so if we were to, let me just get my yellow here. All right, so this graph right here, do we have any idea, like a rough sketch of what this graph looks like? Well, I'm going to look at letter A, what A is and what D is right away. So A is 43, meaning that in a sine graph, instead of going up an amplitude of 1, it has an amplitude of 43. And this also means that it's been, the whole thing has been shifted up 47 units. So if the midline goes up to, let's say, 40, or the maximum would normally go to 43, and then everything goes up 47 units. So this is going to be 47. Here's our midline, and so the sine graph is going to be kind of like this, right? And 43 units is going to be from the midline down to the lowest point. So that's going to be 43 units there, all right? Something like that. Now, it might not start exactly here, right, because it's been shifted a bit, so it's not going to look exactly like this, but a rough sketch should say that we have, a difference from the maximum height to the minimum height of 43 times 2, looks like. So the diameter of the Ferris wheel is going to be 2 times the amplitude, looks like, right? Because you're going to go from the middle, you're going to go up to the highest point, then you're going to go down to the lowest point, and so the amplitude, which is from the middle to the highest point and the middle to the lowest point, 2 times the amplitude should be the diameter, okay? So somebody double check this, in the back there, but I think the diameter of the Ferris wheel should be, what's that, 86 meters? And we're in meters, right? Oh, feet, 86 feet. All right, is that confirmed? Back there for answer of 86. All right, so 86 feet for A. How long does it take for the Ferris wheel to complete 1 revolution? Okay, so 1 revolution would mean from the start point of the graph all the way through to the start point of the kind of the next cycle, right? Or the 1 period length. So period length, we remember, so for B here, this is going to be A over here is diameter 86. So B, the period length for a sinusoidal function is 2 pi over B. All right? So B is going to be 3.5, looks like here. That's the B value. So period length is 2 pi divided by 3.5. And, how long? So we're talking about minutes, so obviously we're going to use a decimal here. That's fine. Okay, so turn that on. So 2 times pi, or 2 pi here, divided by 3.5. It's going to give us about 1.795 or 1.8 minutes. Okay, 1.8 minutes. We okay with that? And that looks great. Now, if it was minutes and seconds, 0.8 minutes, you'd multiply that by 60, that's 48. So also 1 minute, 48 seconds, okay? So that's B. Questions about that, are we good? All right, see how high above the ground is Ashley at the lowest point. So at the lowest point, right here, how high is Ashley above the ground? Again, you consider this 47, right? The midline is at 47 here. And the Ferris wheel has a radius of 43. So 47 minus 43 for C, 47 meters minus 43 meters would be 4 meters. So for C, she's 4 meters above the ground at the lowest point. Yes?
So is the D always the midline?
The D is going to be your midline for any regular sine graph or sine or cosine graph. Yeah. Yeah. Okay, anything else? Any other questions on that one? Or You good? Okay. So that's 8.4, number 12. You're welcome.